Hello everyone. So I wanted to make a video today about alkanes. So in organic chemistry, you have alkanes, alkenes, and alkynes. So alkane is when you have a single bond, alkene is when you have a double bond, and alkyne is when you have a triple bond. And in this video, I'm going to focus on alkanes. I'll make other videos about alkenes and alkynes, but let's get the basics down first. So for the most basic structure in organic chemistry, you have an alkane. So whenever you're drawing the structures, you have two basic methods. You have the line bond structure, you have the skeletal structure. That's for the drawing, right? For writing purposes, you have the formula and then you have the condensed formula. And I'm giving examples as I go along. In this video, I'm not going to be talking about the isomers because there are, for naming purposes, you need to know, for example, what it would be if you have like a tert-butyl or a sec-butyl. And if that doesn't make sense to you right now, it's okay. I'm just going to go over a basic alkane right now, and then we can go and build onto like more complex shapes and structure. So don't worry about that right now. Let's get started. If you like this video, please follow and check out my YouTube channel. So let's begin. So for alkenes, notice that all of them end in ane. Probably should have done a different color, but let me see if I can do one. Okay, so what changes is the prefix or the beginning. I know we're back in going back to elementary with using prefix and suffix and all of that, but I'll try to keep it as plain as possible. So meth is 1 carbon. Eth is 2 carbons. Prop is 3 carbons. Bute is 4 carbons. Pent is 5 carbons. Hex is 6 carbons. Hept is 7 carbons. Oct is 8 carbons. Non is 9 carbons. And dec is 10 carbons. So let's go back. So for methane, is you have a CH4. There's not really a skeletal structure because what would it be, like a dot? Like no, so it's not applicable. The same thing for F. I mean, I guess you could draw that, but that looks really weird. So we don't really do that in chemistry. We just do the line bond structure. But as you can see with ethane, like I literally drew the 2 carbons, a bond between them, and then just added the hydrogens in. And remember that in organic, in general, carbon only has 4 bonds. So that's a huge, you won't see carbon with a 5 bond. No, that's not going to happen. It's only 4. Then you do the same for propane. Now, notice how I drew a skeletal structure. So each dot represents a carbon. So this is 1 carbon, this is 2 carbons, this is 3 carbons. So that's why I drew it like that. I know at first it's going to be extremely weird. You're going to be like, this is weird. But at the end of the semester, I promise you're going to love it because it makes your life so much easier when it comes to drawing than having to write all of those H's. So then when you go to butane, again, you have 4 carbons. But this is where the interesting part happens. You have this CH3, CH2, CH2, CH3. Did you hear me say CH2 2 times? Yes, you did. So what scientists have done is that they made a condensed formula. So they put CH3, the CH2 in parentheses, and then 2 to signify that you write the CH2 2 times, and then the CH3. So that is known as the condensed formula. So as I keep going in the video, I'm going to use the condensed formula. And for the first couple, I'm going to show you the line bond structure, but then I'm mainly going to be using the skeletal structure at the end because it's going to be way too many carbons. So again, whenever you're drawing a zigzag. So first, second, third, fourth carbon. 1, 2, 3, 4. That's how you keep drawing your zigzags until you finish the amount of carbons. So pentane, you have 5. So 1, 2, 3, 4, 5. Then you have hex. So 1, 2, 3, 4, 5, 6. Again, notice for pentane and hexane, I put the CH2 in the parentheses and then I put the amount of times that I wrote that CH2 down. Okay, heptane. I stopped using the line bond structure because, again, it's too many carbons. So let's use the skeletal structure. So you have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8 for octane. For nonane, 1, 2, 3, 4, 5, 6, 7, 8. Oops. 8, 9. For decane, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You might run into 11 and 12, and if you do that, just know for 11, I think it's undecane, and for 12, it's duodecane. I didn't really use it in my organic chemistry class, but if you have to use it, that's what you would use. If you like this video, please follow and check out my YouTube channel.